Welcome to the 24 hours of PaaS, evolution of data platform. We're excited you could join us today for Marko Hotti session. SQL Server 2016 hero features in action, full life cycle of financial data, and SQL Server 2016 in-memory performance. This 24 hours of PaaS event consists of 24-hour sessions that will be delivered by expert speakers from PaaS community. This session will be recorded and posted online after the event. To access on-demand sessions, please visit 24hoursofpaas.com for all session links. My name is Kenneth Urena. I'm Data Platform MVP for Microsoft and PaaS Trainer Mentor Flatran, and also Linchpin People teammate. I have a few introduction slides before I hand it over to Marko. If you require any assistance, please type your question in the question panel located on the right side of your screen, and someone will assist you. This question panel is also where you may ask the question through the presentation. Feel free to enter your question at any time, and once we go to the question and answer portion of the session, I will read out loud to the speaker. You're able to zoom in on the presentation content by using zoom button located on the top of the presentation window. Please note that there will be delivered a short evaluation at the end of the session. Your feedback is very important to us, so please take the moment to complete it. It will appear in your browser. I would like to take the moment to thank our presentation sponsors, Amazon Web Services, Hortonworks, Redgate, and Microsoft. Microsoft empowers users with new insights through familiar tools while balancing the need of IT to monitor and manage user-created content, deliver access to all data types across structured and unstructured sources. In addition, I would also like to thank the support of sponsors for this event, Hewlett-Packard Enterprise, SQL Sentry, and SanDisk. The staging of the 24-hour of PaaS will not be possible without their generous support, and they are the reason for this event to be available free of charge. Make sure you explore also everything else PaaS has offered you as a data professional. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up the latest community news in the Connector newsletter. This session will be presented by Marko Hotti. Marko Hotti has been working with relational databases and data management systems since the early 90s, when he was started as a DBA for Oracle Relational Database Systems, running on Solaris and HP UX. Marko works in Oracle in Finland from 2000 to 2005 as technology consultant, and since 2005, Marko has been employed by Microsoft. He recently relocated to Seattle in the early 2015 to start his new role as a technical product management for SQL Server. Working on that role, he has been working with a lot of customer-facing interactions in order to find different opportunities to incorporate their feedback into the product. So, Marko, welcome to the 24 hours. It's always a pleasure to have you here. You can take over from here.
Thank you very much, Kenneth, and good evening, everyone. So my name is Marko Hotti, and tonight I'm going to talk about SQL Server 2016 hero features. My presentation is going to be kind of an all-up presentation, and when I was writing the abstract, so my idea was to show only demos, but that I was thinking that it's probably a good idea to just quickly go through what are the hero features that we talk about. Hero feature is kind of a term that we use at Microsoft to describe some cool and important features and capabilities that we have in SQL Server, and which we are very excited about, and so it's probably a good idea to go through them first. So just to kind of give you an overview about what we have been doing with SQL Server recently. First of all, engineering for core engine has been working really hard to identify the current known bottlenecks in the core engine. And so we have done lots of blog posts about this, and we have done lots of benchmarks. And this slide kind of shows you the overall results. You can see, for instance, the section where we mentioned that you get lots of performance gains by just upgrading to SQL Server 2016. So for instance, if you're doing data warehouse type of queries using always-on readable secondaries, so you will be achieving 3.6 times faster query results. We have improved the spatial queries and spatial function performance dramatically. There are lots of improvements in in-memory technologies, in NUMA, soft NUMA partitioning technology, and also things like how we do batch and bulk operations. And related to always-on availability groups, so we have improved how we push data, log data streams to the replicas, so you can see even 7 times faster throughput in always-on. We have also been doing lots of benchmarks, both internal and external facing benchmarks, and here are some latest results. We just recently published a new benchmark, which is a TPCH, data warehouse type of 30 terabytes, 144 core benchmark running on Windows Server 2016 on Lenovo. So it's a new data warehouse performance benchmark result that you can go and take a look at tpc.org. And obviously we have been leaders in the data warehouse benchmarks for the past years. So you can see lots of benchmark records for SQL Server and earlier versions. And performance is really a very important topic for us because, you know, the more data you have and the faster you want to process the transactions, the better performance you really want to get from your database. And we work very closely with Windows Server engineering to make sure that SQL Server also benefits from the new innovations that we have in SQL Server, innovations that we have in Windows Server 2016. And so if we think about upgrades to SQL 2016, so it's not only about upgrading to SQL 2016, it's also about platform upgrade to Windows Server 2016, and there we see lots of improvements. For instance, Windows Server 2016 supports 12 terabytes of memory, and currently the max cores that we have tested, so it's somewhere between 480 cores to something like that. The other thing is that regarding, for instance, how you configure always-on availability groups, so as you know, Windows Server clustering is a requirement for availability groups. So, and that means that you previously had to have domain-joined servers to build the cluster. Now there is no need to do that. And we have also improved the security in Windows Server, and that obviously benefits SQL Server 2016 as well. One interesting performance-related technology that is actually a kind of a Windows Server, SQL Server better together feature is Microsoft Storage Spaces Direct. So if we think about the latest innovation in storage technology, so the so-called storage class memory, SCM, such as, for instance, NVDIMM, or non-volatile dual inline memory modules, they are like the fastest flash disk technologies currently available, and obviously that type of storage arrays give you, because they are locally attached flash storage, they give you super fast performance. And so not only your disk space tables, but also durable in-memory tables benefit from that, because the log stream of the durable in-memory tables goes to the local disk. However, the problem with the locally attached storage flash disks has been that it's super difficult to make them redundant. And now with Storage Spaces Direct, it's possible to to build this kind of storage pools where we are using the directly attached storage and create the storage pools that replicate the data across the data centers. And so you will get the benefit of storage area network or SAN technology, but much cheaper. And it's also much faster because we are using the flash technology. Obviously, there's been quite a lot of improvements in other areas, but it's out of the scope in this session. I already talked about the improvements in always and availability groups, and I know that there has been probably a session about the improvements. I just want to call out that one of the features that affect the performance, and that is also like one of the basis of the demos that I'm going to show you, is how to use availability groups and readable secondaries. In previous releases, you didn't really have you couldn't really do load balancing between the readable secondaries to scale out read, and now you can do that in SQL 2016 using the round-robin methods that we have there. We have also increased the number of automatic failover targets, so now in SQL 2016 you can have up to 3 nodes participating in the automatic failover group. And we have improved the log transport performance between the replicas, so we are now pushing the data faster in parallel to the replicas and fully utilizing the network interface that we have between the replicas, so it's a great technology. So this means that now the readable secondaries, when you're building them using synchronous technology, so there is fewer, smaller latency, and obviously if you are doing real-time reporting using readable secondaries, so that will then benefit reporting scenarios. We now also support clustered Columnstore, and clustered Columnstore is a great technology to make sure that you can first of all save disk space if you are using clustered Columnstore indexes instead of heap tables in disk-based tables. But clustered Columnstore is also technology that is related to the new real-time operational analytics that I'm going to talk about a little bit later. And now clustered Columnstore is supported in readable secondaries, so you can actually once you push the primary data to a readable secondary and you use clustered Columnstore, so you can get additional performance impact, and it's an awesome technology that you should be aware of. Other features that we now have in availability groups is better support for distributed transactions, and it's not full support, but partial support anyway. I'm going to talk a little bit about the in-memory technologies, and then later I'm going to show you a demo about the in-memory OLTP. Just to recap, so we introduced in-memory OLTP, also known as hackathon tables, in SQL 2014. And as you know, the idea here is that we keep the table in a row-optimized memory structure in the server memory, and thus we can optimize the transactions, and the idea with in-memory OLTP in general has been that we optimize it as fast and try to make it as fast as possible. So so that has been kind of the engineering goal all the time. However, in SQL 2014, so we saw that not so many customers and partners in ISV started using in-memory OLTP because the T-SQL surface area was kind of limited. And so now in SQL 2016 we have been improving the T-SQL surface, so that those applications that has already been transactionally optimized for short transactions and which are kind of already optimized thinking about the schema, for instance, so they should pretty easily be converted into in-memory optimized tables. The other technology related to memory optimization is to do the native compilation of the stored procedures, and we are actually doing that a little bit differently now that with SQL 2014. Some improvements in in-memory technology. So we now support up to 2 terabyte of user data in durable memory optimized tables in a single database. And one kind of a let's say kind of a bottleneck for in-memory tables that has been affecting the in-memory OLTP performance has been single thread into the disk. If you do durable tables, which means that you can recover the table when you start up the restart the instance. So we are reading the special file stream from the disk, and but it's in SQL 2014 we had a single-threaded persistent thread or log stream, and now in SQL 2016 we are actually doing that in parallel, which means that the faster disk you have, the faster also the in-memory transactions will be for durable tables. Scalability improvements, we have been doing improvements over there, new improvements in dynamic management views, recovery will be multi-threaded as well as the log stream, and so on. DPCC check database performance changed to support 1 terabyte database checks, and the improvement is now 7 times, so we are doing lots of improvements in there. And in-memory OLTP engine has been enhanced to scale linearly on servers up to 4 sockets. This is kind of the promise that we currently have for in-memory OLTP. Then, so if we think about hero features, so in-memory OLTP is definitely is something that we want our customers, our partners, you guys start using and exploring more, because it's great technology, and adding memory to the server is pretty cheap these days. So it's a kind of a cost-effective way of improving the performance of your transactions and all that. Then there is the other thing which is related to how to analyze transactions, and that's where we talk about real-time operational analytics. This is kind of a traditional operational analytics architecture. You know, it's not a new concept. Many customers have actually tried to do real-time operational analytics by querying the transactional OLTP tables or operational tables directly. However, they have noticed that once the very second you start querying transactionally optimized tables, your transaction performance slows down. And you don't really want to do that. Some customers have been adding additional indexes on top of operational tables to support some of the queries that they want to do, but it's not a very optimal solution, because that will also slow down the system. And also the query performance is not very good when there are 2 competing workloads against the same tables. So what they have been doing is they have typically, and this is like what everybody based on my experience are doing, they have implemented some sort of ETL or extract, transform, load type of a process where they are pumping data and data changes from the operational tables to a relational data warehouse or reporting database, where they then optimize the schema for queries and analytical analysis that they can then use through, let's say, analysis services and consume as dashboards and reports. However, the problem here is that it actually requires at least 2 servers. There is data latency in analytics, because you don't want to, you can't really do ETL every minute, so typically you have some sort of latency in the data movement, and it's a little bit complex to implement. And so this is why we introduced the real-time operational analytics, which basically means that we add clustered column store on top of transactionally optimized tables, and when we are querying the data, so the query optimizer realizes that, hey, there is a clustered column store index or non-clustered column store index available for this table, And so it only touches the clustered column store instead of the row store. And so there is a benefit of no data latency. Clustered column store is updatable. We optimize the way how we actually make sure that we catch the latest transactions in the column store architecture. And there is no need for separate data warehouse when you want to do just kind of analytical queries from your operational system. Obviously, if you have several operational systems and you want to do this kind of an enterprise data warehouse, so then you would definitely need a data warehouse as well. And we have great solutions for that, like SQL Data Warehouse in the cloud, which is the MPP solution, and then the APS Analytics Platform System, which is our appliance solution, MPP solution for on-prem data warehouses. And so just to recap, so operational analytics with Columnstore index, depending on whether we are doing operational analytics against disk-based tables or in-memory tables, so it behaves a little bit differently. Obviously, if you have a relational table, which is a clustered index or a heap table, so we add a non-clustered column store index, which is then updatable. We have the so-called delta row groups for the latest changes of the transactional row data, and then it just works. So there's no need for application changes, and the query optimizer realizes and fully benefits of or utilizes the clustered column store technology here. And for in-memory tables where the row store is actually in memory, in the server memory, in a separate structure, so we keep the clustered column store in memory as well, but we have a separate area for the compressed columns that we are then compressing based on the 1 million row segments, and then we have this tail for hot data. And these two technologies, non-clustered column store and column store, in the context of real-time operational analytics, are like super cool technologies. Here is a solution pattern actually based on one of some of the early customer experiences that we have. So we had a customer who is doing fast ETL to a data warehouse type of environment. It needs to be up and running 24/7, so that's why they are using always on availability groups. And obviously when you're using availability groups, so you would be using, you would have a primary and then a secondary. What they did is they added Columnstore in the database, and now that the Columnstore is supported with a readable secondary, so the ad hoc query performance through readable secondary is super fast. And what they also implemented is real-time online analytical processing, or roll-up cube, in analysis services. So basically when they are running reports and using the analysis services multidimensional cube as a semantic model for the business data, so we have the analysis service in real-time mode, and then we just pass on the queries through the semantic model to the readable secondary, and we get real-time reporting, business reporting, using this technology. And since the clustered column store improves the query performance, and we are also now pushing faster the data from primary to the secondary with the multi-threaded log stream, so it's very fast, actually, and we have done some testing regarding this. We've been running, for instance, this kind of a joint benchmark, which is kind of a combination of TPCC, which is a OLTP transactional benchmark standard, and then TPC-H, which is a data warehouse benchmark, and we have been running benchmark loads for both transactions and data warehouse queries against single server and then two servers where we had a primary and readable secondary, and we see that performance is super fast. Okay, then let's move on to some other topics. Performance is very important. One big trend today is advanced analytics, and I think you have all heard about R, which is an open source kind of a lingua franca for data scientists and people who are doing statistics, and it's based on open source community efforts. So R was invented in open source world, and because of that, it's a global community with millions of users, and there are lots of there's a big ecosystem currently, and there are more than 7,000 packages for different kind of data mining and machine learning algorithms that can be used together in advanced analytics. Obviously, the challenge with R is that there used to be a kind of data movement between the data analyst and then with the data. So this means that, for instance, traditionally, if there was a data scientist in the organization, so they typically had someone like a data warehouse administrator who extracted some data, history data that is relevant for the data science, and then handed over this data to a data scientist who was running some R tool on the desktop. And so it was not real time. The data might have changed over the time, so it's not current data. And it was also very hard to operationalize these R models. So if you wanted to just run like operational analytics or operational advanced analytics against new data that's coming to your data warehouse or to your data management system, so it was hardly impossible to do using R. You had to code it in other ways. Now with SQL Server 2016 R services, it's possible to have a single analytics platform which is based on this open source technology. It definitely gives you speed because you can do smarter decisions based on your trained R models. You get faster analysis and faster results based on the new data that's coming in to your data warehouse or to your operational system, and it also allows you to reuse code, because we actually not only have R support in SQL Server 2016 R services, but we also offer the R platform in the cloud, and obviously third-party solution vendors who support R in their tools support, because it's a kind of a standard. So those are the benefits, and we basically kind of make sure that the process and the different roles related to advanced analytics can work using same tools, and there is a kind of a streamlined process to hand over the algorithms to SQL developer, and then DBA can better manage the performance of the analytical platform. So in the demo, I'm going to show you how that looks like. Always encrypted. We actually had lots of security improvements in SQL Server, but if we talk about hero features, hero security features, so always encrypted is definitely one. So always encrypted helps protect data that at rest and in motion. And that's kind of a marketing pitch for this thing. But the idea is that we have a trusted application which is using ADO library, ADO.NET 4.6 or better, where we actually hand over the column master key, which is protecting the column encryption key that is then being used for encrypting and de-encrypting the query parameters, and also the actual sensitive data in the database. So what happens is that when we are using the always encrypted technology, so on the disk, like here in this slide you see you have dbo.customers, so you have two sensitive columns, customer name and social security number. We have enabled always encrypted on those two columns. We have created the column encryption key for those columns, and then we have protected that column encryption key with a column master key, which will be then stored in the secure certificate store on the client side. And so when the database is accessing the sensitive data in those columns, so it basically, or when the client is accessing the data, so it will first request the column encryption key and then de-encrypt the column encryption key with a column master key, and then it's a streamlined process. And this is much better than just using database transparent database encryption or TLS network encryption, because it makes sure that the disk, all the way, the data, sensitive data, all the way from the disk to the buffer cache, and when it's moving through the secure tunnel, and also the query parameter values for these sensitive columns, they are encrypted. So there's never plain text available. And I'm going to show you a short demo about that. And then the last kind of a hero that I kind of want to point out, and it's part of my demo as well, is Stretch. So as you know, Microsoft wants to differentiate from the competition by offering different kind of scenarios where we are doing things differently. Obviously, we are a cloud-first company. We develop SQL Server engine cloud-first, so new features typically come to the SQL database first. We have the Azure virtual machines available for SQL Server, and also we have the SQL Server Enterprise, which typically is an on-prem data center solution. So we were kind of thinking, like, you know, what are the new scenarios to do hybrid IT, and we kind of realized, okay, it's great to have a backup to Azure. Many customers are actually using that, and they are now utilizing the cloud economics. For storing their full and incremental backups in the cloud. You can use encryption together with the backups and so on. But what we really thought would be cool if we could create this kind of a hybrid storage where part of the data that is like hot or is still changing, so that would be stored on those tables in a local local row store using the premium storage that you have, let's say flash disks and so on. And then what we could do is like seamlessly migrate the cold rows or rows that are not changing anymore to a cheaper storage, which would be Azure, and do this without any application changes. So you would still be querying you would still access the data through the same tables, and so stretching really allows you to pick those tables where you have like lots of cold data. In this example, we have order history, which we are now stretching to the cloud, and the SQL Server then just starts migrating the order history and the cold data, cold rows to the cloud service, and you would still access the data same way as you did before. So this is a technology that is we are super excited about, and we want you guys to also evangelize this to your own customers. I know that I have currently lots of listeners who are doing consultancy or who are Microsoft partners, so definitely talk about Stretch and do demos on that. And obviously, since many customers are still worried about the cloud security, so you can complement Stretch database with always encrypted and row-level security, and it actually works with temporal feature of SQL 2016 as well. Okay, so I kind of showed you slides, and I don't want to show more slides because I still have the demos to show you. I want to start with the full life cycle of financial data, which is something that is kind of a real customer scenario that we have been talking about for quite a while. For our in some events, and it's still a valid story of this data services company called pCubed, who is based in South Africa. They are using SQL Server 2016 for processing fast transactions and doing different kind of analytical real-time analysis of their data. And they offer services for different kind of industries. One of that would be financial and banking. And so what they actually have is this kind of a platform for payment card transaction processing and analytics, and SQL Server is being used there. And so what you have here is a customer engagement map which kind of shows this overall global view as to what's happening right now in the world. So you can see some hotspots there, like in Europe and east coast of US. And in southern parts of Africa, we see that there's quite a lot of transactions going on. And then nighttime in Asia and some other areas, we don't see that many transactions. So this kind of shows the overall view. Now that we go to the real-time dashboard, so it's important to understand that behind the scenes, so we are actually running highly availability group configuration with several data centers. We are using in-memory OLTP tables for fast transactions, and because of that, so the average processing time per payment card transaction is very slow. We are talking something about 80 milliseconds per transactions, and we are pushing close to 1.4 billion transactions through SQL Server 2016 in 24 hours. So the transaction rate is great. What we see in this real-time dashboard also is we see some aggregated information. So we see aggregation about how many transactions we are processing per different location or region. So we see, for instance, that in US and Asia there are quite a lot of transactions going on. In Europe, we really don't have that many transactions. But if we look at the reward points that are given based on the transaction type and the transaction sum when you use the credit card, so the reward points that customers are getting are mainly accumulated in Europe region. So that's kind of an interesting finding. To get this kind of real-time visibility to your transaction would have been really difficult with the traditional data warehouse queries, and you wouldn't definitely want to run real-time aggregations through this kind of payment card transaction environments. So there would definitely be latency between what we see in the dashboard and what's happening in the transactions. And so for that, they actually implemented real-time operational analytics. So they added clustered Columnstore on top of the in-memory OLTP tables just to make sure that they can query the latest transactions using the clustered Columnstore. So what I actually have here is a SQL script, T-SQL script that shows that. So what I'm going to do is I'm going to include the actual execution plan. As you can see, so we have a transaction table, transactions underscore CS, that's the transaction table that they are using for payment card transactions. And I run this query. So you see that I get the query result very fast. And now that I take a look at the execution plan, so you will see that my execution plan shows that 100% cost comes from scanning the Columnstore index. So we are really using the different store for catching up, for aggregating the query results. Let's move on the demo. So in the dashboard, we also see that there's kind of a mismatch between how many reward points people are collecting in Europe and what's happening, like how many payment card transactions we are actually seeing in Europe. We see relatively short bar here, and here we see kind of a long bar. So I take a look at what's going on here, and I see now that it's May 2016, so we see that it's we are already above the average base rewards amount, and so we definitely want to see what's going on here, and we want to analyze if there are any anomalies, something like fraudulent action here. And so for that, they have implemented the R integration. So they are using a trained R model to identify potential anomaly in the rewards by month. And basically, the R integration looks like this. So it's you embed R code inside a T-SQL script, and you run that as an external script. So for that, we need to actually enable the execution of external scripts first, so that we can do that, because we are using the fully parallelized RevoScale R libraries to fully parallelize these R models. And now that I run this query, so you will see that that I get actually verification that in the current month, May, we have some anomalies, because this R model is supposed to detect those. Okay, so let's take a look at what's going on in Europe, and we see that there are quite a lot of people who are collecting reward points. I definitely want to see who is the person who is collecting most of the reward points. And so we see that based on reward points, Sally Jones would be the person who's been doing that. And we also see a lot of sensitive data here, like credit card numbers and national identifiers or social security numbers. These are all fake data, by the way, so we are not using their real data in this demo. And so the talking point here is always encrypted. Before, you could do that earlier times, so you would build security in your applications, or you would use security certificates and stored procedures to encrypt columns inside the database. And there's always a threat that if the application developer or the DBA knows on how to unlock the sensitive columns, so they could steal the information. So they are using now always encrypted to make sure that only trusted applications holding the column master key can access the column encryption key that is being used for encrypting the query parameters and the actual data in the system. And so for that, I'm just quickly showing you the always encrypted part. So for that, I have a customer table, which is currently using plain text, or actually this one is already encrypted, of course, because I'm running this against encrypted data. So what I did already before this demo or this session is I used the always encrypted wizard to encrypt these two columns. And now I also have a trusted application that I'm going to run. This is a query data executable. And before I run this, so I'm actually going to run a SQL Server profiler just to see what's happening between this application. So let's run the profiler. I'm sorry that the font size is a little bit small here, but as you see, so there's not much happening right now between clients and the database. But now I start this application, and so you see that this very simple application is querying some customer data and social security numbers. So it's actually the same query that we are running all over and over again. And so now that I look at the profiler, so I see that there's quite a lot of things happening. And if you take a look at this, you will see that the query parameter for value for social security number is actually encrypted using the column encryption key that's in the client side. So we are matching the social security number exactly against the encrypted value in the database. Okay, I will stop this demo, and I just simply show you one more thing, which is the stretch database. So stretch database has already been enabled here. I actually have a transaction history table which is now migrated to Azure. So you see that for this particular transaction table, I had close to 2 million rows, and none of them are residing in the local store in the heap tables on the server. All the data is in Azure. This is actually the original behavior for Stretch. It is now possible to use predicate filters to define which rows are called or not changing anymore, and that are being migrated to the cloud, and which rows will be stored locally. And when I do this query against this table, I'm using the same table, CC transactions, and I run this query. I again enable the show execution plan, and I run this query, so you will see that I'm getting the query result pretty fast. However, when I look at the execution plan, so I see that there was a remote query. The cost was actually not much because it was super fast, and this this data was actually queried already previously, so it was residing in the buffer cache or somewhere in the cache. And so, but the main point here is that with single query, we are actually querying the row store and then the remote row store in Azure. Okay, this is the end of the full life cycle of financial data, and I just want to show you another demo quickly before we go to the Q&A. My original plan was actually to show you this kind of a demo, which is showing not only in-memory OLTP benefits, but also the benefits of enabling clustered column store or using clustered column store instead of heap tables in your data warehouse to give you better ad hoc query performance. And then the third scenario would have been to show you how real-time operational analytics really works in action, but because I basically showed it to you already, so I'm actually going to show you just the in-memory OLTP part. And so for that, I have a connection to SQL Server 2016, and I'm actually showing now the activity monitor. So you see that there's not much going on in my database server. So we are not seeing any kind of resource waits. We are not seeing any data file activity, and anyway, the CPU I/O times and everything is close to 0. So I have this application that I'm going to run here. It's simulating airline ticket reservations. So it's a little bit similar kind of scenario as PQ, but this is a different type of data. You could imagine that this is actually payment card transactions that you are processing using SQL Server 2016. And so the baseline is using disk-based tables, and I'm going to start this demo by running transactions against disk-based tables. And I let it run for a while so that I can get some sort of baseline as to what kind of performance I can expect in my virtual machine. So the virtual machine that I have here on my local laptop, so it's not optimized in any way, but this is the virtual machine is still using, I think, 12 gigabytes of RAM, so there's quite a lot of memory available for this demo, and it's using 8 virtual cores, and I have SSD disks here. But as you can see, so the transaction rate per second is close to 1200 and so on. If we take a look at the activity monitor here, so you actually see the reason why we have why it's not very fast. First of all, we see quite a lot of resource waits for locks, and the more important thing is that we see lots of buffer latch here, which means that the engine needs to wait for its turn, or the worker thread needs to wait until it can access the buffer where we have the updated rows, and so there is a buffer latch which is a kind of a bottleneck. So what I'm going to do now is I'm going to stop this query and for a while and migrate this table to in-memory mode so that I get in-memory tables. And now I'm running the same workload, and I let it run for a while. And now you can see a difference here. So the processor time obviously is a little bit faster because we can now access the data directly in the memory, and the processor always can access the memory faster than the disk, so without any waits, so we are actually using the processor more effectively. What happened here is that a buffer latch is actually 0, and we are not really using any resources for locking. That's actually by design in in-memory OLTP, and the thing that is very interesting is that now, since we are using durable tables, so we are doing quite a lot of logging to the disk. So we see that logging or disk is actually now probably the bottleneck for my in-memory tables. This is why it's very important to start using these new flash technologies like the storage class memory and so on to improve the transactions. It's always beneficial for your environment. And now that I got some sort of improvement, I see that in-memory tables are performing close to 7 times faster in my demo environment. I stop this and then I migrate the stored procedures that are updating the airline ticket table to in-memory mode. So what we are doing now is we compile the stored procedures into a DLL library, which is then loaded to the server memory, and this DLL library can then directly access the row structures in the in-memory section of the server memory, and we see additional performance improvement. So in real-time environment, in production environments, obviously you should see much better improvements, but in this demo scenario it's not like 100 times faster or anything like that, but it's still faster. And so this means that we are actually utilizing the cores and the memory more effectively. And typically the value proposition here is, and this is why many customers are looking at in-memory technologies in general, is that if they want to have high performance, so in previous times they thought that, okay, I add more CPUs, but then there is the licensing impact. The more cores you have, the more you have to pay for the license, and so this is kind of a problem, and therefore we are not. Therefore, it's kind of a beneficial and cost-effective way to improve the performance of your environment using the available memory and use that as effectively as possible. Anyway, that kind of closed up my my demo, but I know it was pretty rushed, but I wanted to make sure that you get the value proposition about the most interesting features that we have. Now we still have something like maybe 6 minutes for questions, so I hand over to Kenneth. Do we have any questions online?
Yeah, Marko, we got quite a few. First question is, if SQL Server is running on SSDs, is there any benefit to have tables as in memory?
Well, if the database, if SQL Server is running on SSD disks, I think that was the question. So this in-memory OLTP may benefit from that in case you are using the durable tables. Because, you know, even in-memory there are 2 types of in-memory tables, in-memory optimized tables in SQL Server, durable and non-durable. Non-durable tables only exist during the lifetime of when the instance is up and running. So typically non-durable tables are created on the fly from the disk-based tables and then just migrated to, or they reside in the server, but we are not persisting the data on disk. However, durable tables persist the data to the separate file group on disk, which is based on log stream and fast write of the log stream. Now we do it in parallel in SQL 2016, so this means that if you have faster disk, SSD or faster for in-memory tables, so you can definitely work faster with in-memory tables. But if we think about other way around, so if we think about you have already made the investment for SSD disks and you are now thinking whether I should promote some of my tables to in-memory mode to get some additional performance. So it's pretty much dependent on what type of application you have and whether these tables or the schema can be migrated to in-memory mode. So for that we actually have in the upgrade and in our tools like SQL Server Management Studio, we have this simple report where you can see which of the tables in your environment or in your database are the best candidates for in-memory mode based on the statistical information that we have, and which are the stored procedures that could be promoted to natively compiled stored procedures.
Excellent. There is another question. Is always encrypted an enterprise edition only feature?
So always encrypted is actually kind of a scenario where I believe we currently have already the data sheet available. So always encrypted is available for standard edition as well, and it's kind of we want to make sure that you can start small with this very important security technology, and in case you then want to upgrade to enterprise, so there is no change to your kind of the application architecture per se. So for that, so we actually have already the edition worksheet or data sheet available, and let me just pull it for you. So while I'm looking for that, so you probably can give me the next question.
Sure. The next question is, which technology is used to show those dashboards for customers' engagement map and real-time dashboards?
Actually, I have to correct my answer. So always encrypted, and I should have known this. So always encrypted is as well as database transparent data encryption. So they are enterprise features only. So could you please repeat the question again?
Sure. Which technology is used to show those dashboards for customers' engagement map and real-time dashboard?
So what technology we were using in the demo. So we are obviously, this is a web application, and we have some additional graphics libraries from GitHub that we are using. So we have been using Visual Studio 2015 to create the ASP.NET application, and then added use some publicly available graphics control that are available from GitHub. But I don't know the details because I didn't really personally build this web app.
Okay. When I restore the database backup from a stretch database to another server, does it expect the same Azure DB connection in the new server?
Could you please repeat the question? Didn't quite understand that.
Sure. When I restore a database backup from a stretch database to another server, does it expect the same Azure DB connection in the new server? What I understand that he's asking is, for example, you have the solo backup for a stretch, and then you need to recover from that backup. So you have to restore that backup in another server. So which server should it connect to Azure? Is what I believe he's asking.
Yeah. So when you use stretch, so you would still take the backups same way. You do full backups and incremental backups, and also point-in-time restore and restore recovery of the database same way as before. So what we are doing when we are doing the backup, we take the normal backup set to from the local row store tables, and for the stretch, so we actually kind of have this kind of pointer in SQL database. We use some SQL database technology there to record the snapshot for the remote store, row store, and when we are doing recovery or restore the database to an earlier point of time, so we just move the pointer and so we get like the previous data back. But it doesn't affect your backup or recovery scenarios. I think the time is out.
Yeah, I think that we are going to have the last question and the rest of the questions that are not getting answered. We are going to follow that to Marko, and
Sure.
he will answer them in a later day. The last question is regarding the in-memory OLTP you were talking about. It said, will we lose the data for in-memory if server crash?
Yeah, so if the server crash, so if you have non-durable tables, so you are not persisting the data for in-memory tables, so you will lose the data in the in-memory tables. If you are using durable tables, so you have the durable option in the DDL statement when you create the table, so you would then use the log stream to persist all the transactions to the log stream, and then obviously also when you do when the server crashes and we do the database recovery, so we just read the log stream sequentially from the disk and rebuild the in-memory tables from that. So it's part of the recovery process to recover also the durable in-memory tables.
All right, Marko, I really wanted to thank you to the presentation on all the questions. We actually run out of time, and it was a really interesting session. So
coming next.
Yeah, coming next. Elastic Database Client Library and Elastic Database Transactions with Sylvia Dumbra. There has been really great presentation tonight, and I'm pretty sure the one in Sylvia is going to be outstanding. Thank you everyone for attending tonight. Please keep in touch with 24 hours and enjoy the next session.
Yeah, thank you everyone, and have a good night or rest of the day. Bye.